thank you all. I would like to thank AFRI and GDG for inviting me to speak here today. As you can see, I'm in cloud engineering in Google. And this is a pretty technical discipline. So you might be wondering, why is this guy here talking to us about sustainability? And the fact is that this topic is really at the heart of all workloads that run in Google, both cloud and other. And a while ago, some of us at Google started writing a white paper and making calculations about sustainability. And we learned that companies typically reduce their energy use and carbon emissions by using Google Workspace. And you know what the percentage of emissions reductions was that we found? It was 87%. So then we did some more digging and we thought, okay, what about just Gmail? If someone goes from on-prem servers to using Gmail, what's the typical reduction in carbon emissions that they use? And the answer came out to be 98%. So these numbers seem really interesting. So we thought, okay, this means as a developer, if you're using these tools, you're not just getting great collaboration, you're also helping the planet. So it seems worthwhile to spend some time telling you about the infrastructure and systems that make these outcomes possible. So first off, it turns out that doing the right thing for the planet and doing the thing that makes sense for business is actually the same thing. Sustainability doesn't just improve the outlook for the environment. It lowers costs by reducing waste. It improves your situation for regulatory compliance. It attracts employees and investors who are also interested in sustainability. And it improves your brand by attracting customers who are interested in those values when they decide to buy something. So if your team is interested in these things, then this is a pretty interesting topic. And sustainability is set on really clear science. 2019 was the second hottest year ever recorded. Ocean temperatures are the highest they've ever been. The scientists behind the report that produced this at NASA and NOAA show that pretty conclusively carbon dioxide and other greenhouse gas emissions is what's behind the warming. And according to a report produced by the World Wildlife Foundation, if we just continue business as usual, that's going to cost us about an extra $1 trillion. So, but this doesn't mean that everything is doom and gloom, right? The game is not over. We work with data. We love data, as you're going to tell by this presentation. And we care about our users and our impact on the world, but also society and the environment in particular. And we like to be hopeful about solving problems at scale. And we like to do it for everyone. This is a quote from Google's CEO, Sundar. And if you read the blog post where this came from, he talks about this very personally. He talks about how he grew up in Chennai, where there were floods after years and years of endless drought. And then he now lives in California. And then last year, the skies over California turned orange from all the wildfires. So this is a real and personal topic for us, right? And his message is we care and we have a plan. And I want to share that plan with you today. But it's not just Google that plays a part in this. It's all corporations. And the industry, right, contributes as a whole to total global emissions. But why is IT so important? Well, millions more people come online every month. And the demand for computing power continues to skyrocket. And data center capacity keeps increasing. But despite this growth, the total amount of electricity used by data centers has stayed more or less the same. So the total amount of data center computation increased by about 550% from 2010 to 2019. But the amount of electricity consumed only increased by 6%. But as mobile device usage continues to increase, there's more transition to public cloud. The industry has to do better than just holding the line. We have to lower it so we can serve more while using less resources. And this is going to become more and more important because we're moving to more and more data-intensive systems. AI, ML, Autonomous vehicles, all of these things are going to increase IT demand. So while we've made great progress so far in improving IT efficiency, and I'll talk about that more in a moment, we have to make sure we continue to improve to offset and even exceed the demand growth that we know is going to continue. So what can we do, right? How can we be agents for this change? Well, Google thinks about this in two ways: greening of IT and greening by IT. So greening of IT is adopting technology that's built with sustainability in mind. And this reduces the immediate impact of your IT operations and lowers your associated emissions. Greening by IT is using technology to reimagine your solutions in your business to become more sustainable. So let me talk more about what Google does specifically for both of these things. When we break it down, we have 4 pillars, right? The first 3, smart and efficient data centers, renewable energy and carbon neutrality, circular economy, is greening by IT. The last one, data-driven innovation, supports greening of IT. Sorry, I think I said that the wrong way around. The first 3 are greening of IT. The last one is greening by IT. So now I'm going to jump into each one of these to give you specifics. Let's talk about the first one, smart and efficient data centers. So for decades, 2 to be specific, Google has worked to make our data centers some of the most efficient on the planet, right? So we've done this by designing, building, and operating each one to create a maximized efficiency for energy, water, and materials. Here's some examples of what we're doing. First, our server hardwares are pretty efficient. We've been designing our custom servers to minimize energy use since 2001. By using highly efficient power supplies and putting batteries directly on the machines, we've built some of the most efficient servers on the planet. Second, we've designed our chipsets to be more efficient. Our tensor processing units are designed with energy efficiency in mind, specifically to accelerate deep learning algorithms at higher teraflops per watt compared to GPUs. Second, we use smart temperature and lighting. We've improved facility use by installing smart temperature and lighting controls and redesigning how power is distributed to reduce energy loss. The way we build floors, ceilings, walls, the airflows, the hardware layouts, it's all designed to maximize efficiency. Third, we use innovative water sourcing. So one of the primary sources of energy consumption in a data center, as you may know, is cooling. So we employ advanced cooling techniques, relying mostly on energy-efficient evaporative cooling, and use non-drinkable water at some sites. At other sites, we reuse waste heat generated by our servers to heat our data center offices and other facilities. We're also practicing sustainable water management in our data centers, while we keep working to find innovative cooling options. So for example, we have a data center in Hamina in Finland that uses seawater. In Belgium, we have a data center that uses industrial canal water. In fact, it goes through multiple stages of filtration and gets put back into the water system cleaner than when it came in. In Ireland, we use air cooling techniques. And then on top of that, we actually use AI in our cooling systems. So every 5 minutes, the cloud-based AI system takes a snapshot of the cooling system. That's actually represented by thousands of sensors for each facility. And that information is fed into neural networks that then predict the future energy efficiency and temperature, and then provide predictive feedback actions back into the system. The result of all of that is that we see the payoff, that on average, a Google data center is twice as efficient as a typical enterprise data center. And compared with 5 years ago, we have 7 times more computing power delivered with the same amount of electrical power. The last number is especially interesting. Our average trailing 12-month PUE is 1.10. Let me explain what that means. Power usage effectiveness describes how efficiently a data center uses energy, specifically how much energy goes into the data center compared to how much is actually being consumed by the equipment running those workloads. In other words, it's the ratio, right, between how much energy you're using for actual computation and storage and network versus all the energy you're using as a surrounding overhead. We take the most comprehensive approach to measuring PUE. Our calculations include the performance of our entire fleet of data centers around the world, not just the newest and best ones. And we continuously measure throughout the entire year, not just the cooler seasons. And we include all sources of overhead in our efficiency metric. We could report much lower numbers if we took an industry standard interpretation of PUE, and then actually our best facility would probably hit about 1.06. But we think it's most useful to stick to a higher standard because we think it's important to optimize everything. So we actually present a industry-leading average of 1.10. So the industry average is 1.67. So on average, we have between 1/6 and 1/7 the power overhead of the industry. So then let's talk about the second pillar, renewable energy. So what is Google doing in this area? Let's first start by defining the terms. Carbon neutral, right? This means offsetting all the carbon that Google has ever emitted, right, through renewable energy purchases and carbon credits. Renewable energy means that all the electricity that we use annually is matched with purchases of renewable energy. Carbon-free, for us, means that Google runs the entire operation in every part of the world for every hour of the day on carbon-free sources. So these terms are important because if you look at the market, people can obfuscate a little bit on what they mean. We've made these commitments in every case ahead of our peers. For example, we match 100% of our electrical use with renewable energy purchases. We hit this target in 2017. Some of our peers are promising to hit it in 2025. So what that means is we match every unit of electricity we consume around the world with an equivalent unit of electricity from zero carbon sources. This is on a global basis. So what this means is if you use Google services in any shape or form, you're already matching your consumption with renewable energy and your net carbon footprint is zero. But now I want to talk about our biggest moonshot to date, which actually has a lot of technical complexity behind it. We're the first major company that's announced to commit to carbon-free energy 24/7, and we want to be the first to achieve it. So we define carbon-free energy as the production of electricity without any direct emission of carbon dioxide. Essentially, we want to fully decarbonize our electricity supply. So 100% renewable milestone means that we buy enough renewable energy over the course of the year to match our consumption. For example, right, we matched 100% in 2019, but that year, if you looked on it hour by hour, only 61% of that energy was coming from local regional carbon-free sources. The issue with trying to get it to 100% is that, you know, wind and solar power don't always work, right? Sometimes the sun doesn't shine, sometimes the wind isn't blowing. So to compensate for that, we buy a surplus of renewable energy at other times in other places, right? What we want to do instead is go to becoming fully dependent on carbon-free energy at all times. And to get there, right, we're going to have to source carbon-free energy in all of our locations on a 24/7 basis. So we're going to do things like pairing wind and solar power sources together. We're increasing our use of battery storage, and we're working on ways to apply AI to optimize our electricity demand and forecasting. And we think that by doing this, we're going to accelerate the availability of clean energy in communities worldwide and solve the challenges that have held it back from becoming an around-the-clock source of energy for the global communities. And by the way, we actually last year issued $5.75 billion in sustainable bonds to enable those projects to happen. So to make this transparent, we've made available global views of our carbon-free energy percentages, right? And we have our carbon-free footprint tools, so you can see the actual level of carbon-free energy associated with your workloads. So what does this allow you to do? Well, you can pick a lower carbon region, for your application if you can. You can run batch jobs on lower carbon options, and you can set policies for lower carbon regions so that you're always running your workload in the place with the most carbon-free energy. So we're trying to make it as easy as possible for our users to become sustainable. Let me move on to the third pillar, which is circular economy and zero waste to landfill. So what is a circular economy? This is a model that's restorative and regenerative by design. Products, components, and materials in a circular economy are literally made to be made again. They're created to be easily refurbished, repaired, reused, and recycled. So how do we get there? So these principles are at the heart of our approach, and they're inspired by our work with the Ellen MacArthur Foundation, who's our global partner for circular economy. And they're designed to promote consistency and replicability across our business. And these three principles are: first, to design out waste and pollution. So circularity must be incorporated basically from design, from the beginning. So things created today become the resources of tomorrow. We also have to eliminate the negative impacts of economic activity that cause damage to human health and natural systems. Second, we aim to keep products and materials in reuse, so that we basically design to keep things in production as long as possible, right? So you preserve the embedded energy, labor, and materials. As an example, in 2019, 19% of the components we used for machine upgrades were refurbished inventory, which avoided tens of thousands of tons of equipment waste. When we can't find a use for our equipment, we aim to erase those components completely and then recycle or resell them. So in that year, we resold almost 10 million units into the secondary market. And finally, we look to promote healthy materials and safe chemistry. So to keep materials flowing longer in the economy, we have to design them to be safe for human environmental standards, because we can't change the chemistry once those products are out there. Each of these topics is quite lengthy, and it has their own KPIs, their own measurements, their own metrics. But the basic message is that when you run things on Google, you're already following these principles. Let me come to our fourth pillar now, which supports greening by IT, data-driven innovation. No one company can change the course of the planet, right? So we believe we need to work with others to make our world more sustainable. The DeepMind for Google team applies DeepMind's research to Google's products and infrastructure. And in 2016, DeepMind and Google made an AI system to autonomously manage cooling in Google's data centers, while remaining under the supervision of our operations team. Then 2 years later, we started applying ML to 700 megawatts of wind power capacity that we purchased in the central United States. So the idea was to increase predictability and the value of the wind power. And by using a neural network trained on weather forecasts and historical turbine data, they configured the DeepMind system to predict wind power 36 hours ahead of its actual generation. So 1.5 days ahead, we were able to predict when and where and how the wind would be blowing. Based on these predictions and other research, we could then figure out how to make optimal hourly delivery commitments to the power grid. And as a result, we were able to reduce our power consumption in our data centers by 30%. Now we're opening up this technology to the world so that enterprises, building management companies, data center operators are able to take on the same efficiencies. So basically, I want to invite you to discover how our infrastructure and Google services can make your workloads and business processes more sustainable and work together. So I think at this point, I'm happy to take questions, and I hope you're going to enjoy the rest of today.